This question showed up as a 6-point question that actually involved a football being kicked. But I've changed it to Barry hitting a baseball whose path can be modeled by the function h of x is negative 1 over 300x squared plus 1.31x plus 3, where x is the horizontal distance from home plate and h of x is the height of the baseball above the ground when both are measured in feet. And the set of axes below graph the function over the interval from 0 to 400. So I'm going to pay attention to this because this is going to allow me to cheat on my window. The other problem that this question presented is they gave us an axis, but they didn't give us a scale. So that created a lot of problems for students as well as one other issue that happened when they looked at the graph. So I'm going to approach this graphically. Negative 1 over 300x squared plus 1.31x plus 3 is the formula that I'm going to graph. I'm going to add a new page to accomplish this. It's a graph. My h of x is negative 1 over 300x squared plus 1.31x plus 3. You'll notice again that I have a picture that looks like a line that starts and goes up, and this was the biggest mistake most students made. They looked at this graph and thought this is the only part of the graph that's applicable, and everybody's graph looked just like a straight line, when in truth it's got to be a quadratic that's curved. It's going to go up and then fall down because it's negative x squared. So we needed to zoom out. After a few zoom outs, I can now see the entire picture. I can see where the ball goes up. I can see its maximum height. I can also see where it lands. Okay. Now what I need to do is I need to graph this. Transfer this from the graph to my paper. So I'm going to cheat a little bit. I'm going to analyze this and find its maximum. I'm not going to change my equation. I'm going to analyze this and find my maximum. And the maximum height that it achieves is 132 feet when it's 197 feet from home plate, and they want me to model this up to 400. So I need to go up 132 feet on the y-axis, and I need to go to 400 on the x-axis. 132 feet on the y-axis and 400 on the x-axis. So what I thought about doing was making each one of these hash marks along the y-axis 10. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. And that's going to cover at least my horizontal distance, or vertical distance. Along the y-axis, I need to be able to go to 400. And there's really not a right or wrong way to do this. You can develop your own scale as long as you identify it. I chose to use 20 for each increment along the x-axis, which means I'll have 20, 40, 60, 80. This is going to be 100 feet from home plate, 120, 140, 160, 180. 200 feet from home plate, 220, 240, 260, 280. 300 feet from home plate, and finally 400 feet from home plate. It's probably a good idea that I label my axes as height and distance from home plate. And now I also know the fact that this is going to be a curve that reaches a maximum height of 132 feet at 190 when it's 197 feet from home plate, and 197 feet just under 200. 132 is going to be approximately right here. If I want to, I can go into the table or use the trace command to get more distinct points. And what I'm going to be interested in is, for example, let's see what it happens when it's 40 seconds. 40 feet from the home plate, it's going to be 50.1 feet above the ground. About here. After 100, when it's 100 feet from home plate, I'm going to be about 101 feet in the air. And now I really start to have the makings of a curve that I can use as a mirror image. I guess it's important to know when this is going to actually hit the ground, so I'm going to move my cursor to the right until I find the 0, which occurs 395 feet away from home plate. It'll be 0 feet above the ground. So 395 feet, it'll be 0 feet above the ground, which is about right here. And I'm going to draw a rough sketch of the flight of this ball, making sure that I have it land about 395 feet from home plate. I'm going to label this h of x. And now I've got a decent graph. Determine the vertex of h of x. Interpret the meaning of this vertex in the context of the problem. So the vertex we found was the maximum point, which was 197 and 132. So the interpretation that we have is when the ball is 197 feet from home plate, it will be 132 feet above the ground. And then the last thing it says is, will the ball be high enough to pass over the fence if at 380 feet away, 380 feet from home plate, there's an 8-foot fence. So I'm going to go back to my graph. 380 feet is along my x-axis. So I'm going to type in 380 feet. And I hit enter, and I find out that 380 feet away from home plate, the ball will be approximately 19.5 feet above the ground. Because it's 380 feet from home plate and it's 19.5 feet in the air, it will clear a fence or go over a fence. Go over a fence that is 8 feet tall and 380 feet from home plate. And then I would add that it will actually be 19.5 feet above ground at 380 feet.